This is an imaging XPS dataset. It's imaging in the sense that these data have been measured by stigmatic imaging, and these images are acquired at a given energy. So if we have a range of energies of these images, then we're dealing with XPS, meaning spectroscopy. That in principle, if we sum all of these pixels on these images and assign the intensity to each one of these energies, then we have constructed a survey measurement over the energy range that these images span. If we can identify a set of pixels that have some commonality in terms of chemical state or chemistry, then we ought to be able to pull out a spectrum that corresponds to a precise zone on the image, and therefore we can identify spectra that come from different places that do not have chemistry in common, but they have specific chemistry that we would like to understand. I'm now going to illustrate a very basic mechanism that allows these data to be converted to spectra based on regular zones over the imaged area. So if I go to the imaging processing dialog window, I can go to the image quantification property page, and there's a button that says define image by zones. Now before I do that, I will return to a 2D display and overlay the data, then press the button that says define image by zones. I have no zones defined on the image. If I'd drawn out boxes and pressed some other buttons that would create zones, then I would have zones. This dialog window would not appear. But because I have no zones, it offers me these default settings. So these represent a list of different color grids that can be applied to these data. And I'm going to illustrate the color grid simply using squares. And when I press OK, we see a set of squares with different colors that are related to the area that we see here on the image. And for each one of these colors, pixels will be summed corresponding to the position of the colors in this image, and spectra will be produced. And because this image appears up here, it means the color mask is active, so I can say sum spectra using colors. And then I end up with 16 different spectra, which I can see if I use 16 tiles, and I can correlate these spectra with the colors if I use some options on the colors property page of the tile display parameters dialog window. I need to use the palette of colors for spectra, not the color scales. I need to select that I want to change the color for each tile, and since I'm going to apply this to all tiles, I'll go to the global property page, apply to all tiles, and then press apply. So we now see spectra that have been collected from those images, and they represent different parts of the image surface. So over here we have the top left hand corner of the image, and it looks very much like it's the glass. We've got silicon, carbon and oxygen and various other elements. We go to the opposite side and we see silver 3D, some carbon, some oxygen. So we can see that in the top right hand corner of that image we've probably got a material that is very different from a glass that we see over here.